What do we learn today? I have to actually look at the
Just some more SolidWorks FEA tutorials. I'll run through it in a second.
sweet.
Here he is.
Took his time.
Took his time.
All right.
Like I waited for.
Start now.
5 past anyway. All right. Welcome back to week 2 of FEA. Now, what you will be going through, if you go to week 8 to 11 FEA tutorial 2, you want to go through this document here. Just looks like this. Now, what we're focusing on is these 4 tutorials here. Now, very similar to last week, each one of these tutorials is designed to introduce you to a principle of finite element analysis and basically show you something that's beneficial. This week's more about demonstrating the capabilities and demonstrating different ways to simplify your model or different ways to set it up to make it easier for you in the long run. Last week was very much about understanding the effects of singularities and what the limitations of the FEA actually are. But this week's a bit more instructional, makes it a bit easier to set things up. So number 1, symmetry restraints. Can anyone tell me what the 6 degrees of freedom of a node are? Anybody?
X, Y, Z roll picture.
Yeah, or XYZ translation, and then rotation about the XYZ axis, which translates to the same thing. What you're doing when you're setting up symmetry constraints is along these edges, so you take a slice out of your model, and then along these edges, you're reducing the degrees of freedom of the nodes on those edges, so that when the model is calculated, it acts along those edges as if it's attached to the rest of the body. So all you're doing is simplifying the degrees of freedom on the sides or on the edge that you've selected for a symmetry restraint. Now that's important because instead of trying to calculate this entire body, you can take a slice out of it and you can just solve that, reducing the amount of nodes and the amount of elements that you have to calculate or solve, meaning that you have a much more simple problem to deal with, which means you need less computational power, which means it'll take less time. But because you've identified the fact that it has rotational symmetry in this case, you can make it a lot more simple. Next, you want to look at bearing loads. So bearing loads are important to understand because, as you can see from this force distribution on this hull, when you're actually applying a load to a radius like this, you get what's called a sinusoidal distribution, and that sinusoidal distribution is dependent on a function. Now, this function may be different for different applications, and this tutorial shows you how you can actually change that, the equation that defines the distribution of this force, so that you can run your simulations accurately to what you're expecting. But if you're pushing down on this hole with an evenly distributed force, you'd have a nice square edge here, then you'd have a nice even distribution across the whole thing, which in reality is not how a bearing load works. Now, a bearing load can be something from, say, just a shaft or a bushing. It doesn't have to be a bearing specifically, but this sinusoidal distribution will provide you with a different stress response in the material. So it's very important to understand how these actually work. Number 3 is remote loads. So again, simplifying something, say you want to apply the force of a tire on, say, a suspension system, but you don't want to include the tire in the model. You can simulate the contact patch of the tire to the road and apply a force from that point onto the suspension system without there actually being a tire in the model. You do the same thing here. You simplify this by halving the model. So you remove half of the beam and then you apply a remote load on the end. And then finally, you can do some beam diagrams. So beam diagrams in this are useful But like we've said before, this is only a tool for validation. You should always double check with a free body diagram or a bending moment diagram, and then verify it using this software. Any questions from any of that? Perfect. I will run through some stuff about the assignment a bit later. What we will do is just talk about some of the stuff that you guys need. We'll run through the marking criteria, and then next week or the week after, if you guys have any questions, I'll be happy to answer it. The tutorials that you've done up to now, you could probably get started on the assignment if you guys are feeling up to it. The first few questions should be quite simple once you've done this week's tutorials and gone through the lecture content. So I'll be happy to answer questions about those next week. All right, let's jump into some breakout rooms and we'll get started.
Hi guys, how's it going?
Not too bad, I guess.
That's good.
Hello?
Hello.
Not too bad, I guess. Yeah. I was just wondering, do you know how I can add the SolidWorks tutorials into the since I can't seem to be able to find it?
Yeah, I'm just trying to figure out that out now myself, actually. Forgot where they are.
Yeah, since I've checked the add-ins and it doesn't seem to be listed under the premium add-ins or...
Oh, so you go, so you know how you put your mouse like top left, there's that arrow, then like file, view, tools, and help pops up.
Yeah.
And then go help, and then it's under help, it's SolidWorks tutorials.
Oh, okay. Right. Okay, I see now. Okay, thank you.
No worries, mate.
I'll share my screen if you guys like. We can
Yeah, sounds good, mate. Sounds good to me.
do this together. It's a big happy family.
Where do we actually find which ones? The simulation in SolidWorks, and then
where is it again?
oh yeah, it's under static analysis. That's right. Okay, symmetry restraints. Do it.
It's up here. I'm just having a dumb moment.
You go help. No, go on the left.
Yeah, that's right. And then tutorials. And it's taken me to the wrong screen. Of course it has. Stupid fucking software. Okay. So we're doing like our first part, aren't we?
Always.
It's this
How's
one.
it going, mate?
Good. How you going, mate?
Great. I'm gonna try to get this shoot done so I can go to the beach, really.
Oh, mate. I'm going go-karting this afternoon.
Oh, nice.
Where at?
Homebush.
Oh, nice.
That's sick.
With John Reeble.
Oh, yeah. That's awesome.
Yeah. Me, him and his girlfriend are going go-karting.
Is tagging along?
Yeah. Well, she's tagging along, actually.
We're getting in the middle of the bromance.
Yeah, that's it.
Symmetry restraints is this one, eh?
That's the one.
Okay, click here to open the document. Yes.
Oh.
Oh. That is a nice looking
Why did you...
bean.
Campbell, why did you say we only look at a quarter again? Forgot. I was a bit zoned out. It's like to simplify like just the calculations.
Yeah, well, if you break that down into a certain amount of elements, it's less than if you're doing the whole body, which means you've got
Oh,
less
so-
calculations to do, which means it's an easier
Oh.
solution,
Okay,
easier to
so
run.
it's just, but like, so it's not necessarily like easier for like you to set it all up. It's just like easier for you to get it from it.
Yeah, it's just more simple. Yeah, it's less calculations, less features,
Gotcha. Okay.
and there's rotational symmetry and planar symmetry. So you can have something that's symmetrical on either side of a plane, or symmetrical about an axis.
Yep. And this is rotational.
Correct. So if you can chop out a wedge of it, like we have here, and then apply symmetry restraints, then like I said, it just on that edge
Roughly.
there, and that
We
edge
go-
there. Oh, wow, that was terrible.
Ah.
Do we have to create a new study? Yes.
No, so there you can see down the bottom here.
I can't actually see your screen. I can only see James' screen.
Yeah, I'm highlighting on James's.
Oh shit. Wait, let me just.
These ones?
I have. Well, just need to like. Full screen it. Oh yeah. Okay, gotcha.
Yeah, so it has studies already set up, James.
Sweet. I
Oh,
fully
does it?
read that, but I was like, oh, I didn't know what it meant, so I just couldn't keep going. Alright, sweet.
Ah, where do we go?
So.
Hey?
Advanced? Is that where we're going?
And you want to look at this? Or...
Symmetry. Planar.
Oh.
Oh, down here.
Yeah, so they're already set up. A lot of the stuff that you're doing is already done.
Ah. So I'm just going to stop myself there and I'm going to click over here.
Yeah. There's your force already applied, and now it just wants you to apply your fixtures.
Okay, so now we go into here. Fixed geometry. Advanced. Symmetry. And then we click these bad boys.
Correct. Because they're the features.
Oh,
basis
yeah.
That you have for symmetry.
It's like a pressure cylinder, yeah.
Because if you think about the sides or the faces that you're trying to restrict the degrees of freedom on, to act as if they're attached to the rest of the body, then those are the faces.
Yeah.
And now
Fixed.
this next step is purely to give it a fixed point in space, so it doesn't disappear into infinite virtual space and never
You
finish
clicking
calculating.
that little point on the tip.
Have I done that correctly, sir?
Yes, sir. Yes, you have.
Thank you, sir. Excuse me, sir. Okay, see.
I don't know if I like that.
Sir.
Create mesh.
It's mesher. Under mesh parameters.
What are the recommended mesh settings?
There's the link there. It's a hyperlink. You can click it and it'll tell you.
Okay, I was scared that I was gonna like open it each other, but yeah, sweet. I'm like, I didn't want to click it. Alright.
This is
Oh.
something here.
Oh,
Okay.
I'll be back.
Bye. Okay, we've meshed her.
Did you change your dimensions, or you just left them in inches?
I changed into mils because I'm just that
Yeah.
kind of guy.
Where's the global size? I don't even have like all those options.
Oh, really?
Oh no, sorry, they're just like the icons. No, I do.
Oh, whoops. I fucking click on the define show.
Solid.
Define stress plot.
That.
Did you select automatic trials for solids?
I don't want to change it to PSI. Sorry, what was that?
Did you click automatic trials for solid?
Yes.
Sweet. I'll go back. Done. Mesh complete.
Okay, what's...
Where's the simulation tree? In the simulation study tree, right click results. You have to run the study first, hey?
Yes.
Yeah, sweet. Just checking. Just checking if you're paying attention.
Mesh information not current model might have been updated or mesh element size tolerance is modified. Have I missed something? Other than changing to PSI, because we're not going to use freedom units here.
Oh, wait, so did you change your measurements back to inches?
No, I left it.
Yeah, one sec.
Ah, there we go. Okay.
Even if we leave it in millimeters, it doesn't matter. It's still the same. So.
Yeah, that's true.
Wait, where's that?
Fixtures.
Since I'm not saying something like that, in my case, it just looks like I've got a repeat of the pressure vessel default state.
What was that?
You know how it's the trees are broken up into two down the side. It's this looks like a copy of it.
Sorry, it's a bit hard to...
Yeah, it was a bit. Sorry, go again.
Yeah, it's... Maybe can you speak a bit closer to the mic, maybe? Or...
Yeah. It doesn't seem to have a properly known to advance with symmetry forming. No partial solid study that I can see.
Oh, for the solid study bit. I just clicked all those options that said solid study. I wasn't actually really sure what it was. Is that what you're asking?
I'm not sure. I might be. It's just that mine seems to look pretty different.
Did you want to share your screen?
Yeah.
Okay. See if I can. Wrong one. Sorry. Okay. Yeah, so my setup seems to be like that.
I can only see
Can't
the
actually see
SolidWorks tutorials. I can't see.
Cool.
It might have the. Do you have like dual screen set up at the moment?
Yeah, I have a dual screen.
Ah, it'd be on your other screen then.
Okay, I'll just why?
Got a few tabs open there, buddy.
Yep, I'm just trying to get to work. Okay.
Hey, there you go.
Yeah. Yeah, so that seems to be able to see something like that.
Oh, go to the go down a bit, down. So see like just above there, we got like the 3D model thing, and then there's a thing that looks like options. Can I draw on the screen?
No.
Annotate. Here we go. This bad boy. So, oh wait,
No, you're in the wrong thing. So you need to go partial solids at the bottom, don't you?
Solids.
Yeah. So down here, see.
Right?
There you
Yeah,
go.
and then there you go.
I see. Okay. Sorry.
That's right. Hey, James, are you doing the next bit, the shell, partial shells crap?
Yes.
How do you activate the shells configuration?
Hang on.
Do you want me to show you?
Oh, he's back.
Oh no, I think I found it. You just go configurations and then you just right click. You just double click the shells.
Correct.
Yes.
Just here in
Already
the
done.
shoot cam, it already had edge 1 and 2 selected for fix. Do we want them there?
No.
Just the point.
Yes.
Okay. I don't know why they were in there. Just when I opened it, it was there. So.
Yeah, right.
Right.
No, because that'll stop translation and rotation about every axis for all of the elements on that edge.
Yeah, that's what I thought. So I just wanted to just double check and make sure that I wasn't being a dummy.
You weren't being a dummy.
Oh
You
look,
were not.
So the 6 edges are like this. Okay, I get it.
oh, it's a thick boy.
Boy.
Thick boy.
You double click on stress on the left hand side. It'll bring up your stress plot.
So this shell thing, it just turns it from being like a Wait, is it thickness? Is it thick or is it just like a plane basically?
So what it does, I'm going to draw on your screen, James.
Yeah, go for it.
You got a tetrahedron, right?
Yeah.
These have nodes at every corner. And if it's a second order element, you've got nodes along each edge. You end up with 10 nodes, yeah?
Mm.
The shell element
Lost my
is
headphone.
2D. Wow, that was a terrible one. Let me do that again. It's 2D.
Yeah.
Have a node at each corner. And then if it's second order, you'll have a node along each edge. This has 10 nodes. This has 6. All you're doing is simplifying the model.
So you're just turning the tetrahedron into like a triangle basically.
Well, it's not actually a tetrahedron. It's purely a 2D element.
Yeah, when you go to shells, it goes from like 3D, like tetrahedron, to a triangle, basically.
Yep. Now, James, if you click Shell Manager for me.
Am I
At the
still
top.
watching? Or...
Oh yeah.
Now, down here is where your shell feature is defined. So you can see this is where you set your thickness, your units, and your material. And then you can actually select what body or what you're actually using as well. So if you click this button here, and then click the actual body itself, you've defined that whole surface. That's what you're going to be selecting. Then you can choose from these values here. So thin or a thick feature. This is thin because it is a pressure vessel with a thin wall, so it's thin. Middle surface. So what you can do is you can actually change
What you see?
when it interpolates, which direction it interpolates from. So at the moment we're calculating it through the center of the material, and it'll interpolate the values both ways from the 2D elements. But you can say, start at the bottom and interpolate up, or start at the top and interpolate down. And then you select your material, your thickness, and you're done. That's how you define your shell elements. Cool.
Cool.
Does that help, Asher?
Yeah. Kind of. I was just worried because I read it said 0.5 mil thing, and when I was selecting the edges, before I got scale, I was like, I might press because it had a thickness. I thought there's 2 edges, but it's basically 1 edge. Yeah.
Yep. Yeah, it's just a way to simplify your model into an easy to calculate, easier to calculate model.
Yeah, gotcha.
How's everyone else in this group going? Anyone got any questions?
Not at the moment. Just working through it.
Cool.
FEA. What was the next one? Was it the bearing loads?
Yep.
Cool.
Shit. I ran the study. I don't know if I changed the automatic transition. After you select all the fixes, James, you just went run the study, yeah? You didn't have to do anything else?
What's that? No, I just ran it and that was it.
Alright, sweet. Do I just save this somewhere?
Alright, I'll check on the other group. I'll be back.
Where's Matt?
Wait, was it this one? Opening the part. Okay. I'm assuming
What's the next one?
applying bearing force. Files.
Are you doing the bearing loads one?
Yes.
It popped this out. Okay.
Ooh.
Partial bearing loads.
Select the lower face of the central hole. It's already selected. How good is that? Oh, it's in yuck. It's in yuck units. I had to change it. Select coordinate system 1. Okay. What was it? Yeah, it's already in freedom units. Sinusoidal distribution.
In the property manager, click in cylindrical faces or shell.
Right click. Oops. I meant create the mesh. That one. Okay, 4. Draft quality. What? Oh, cleared. Right. 3.
My units are in newtons. For yours? Or was yours in
No,
pound force?
mine are in freedom units.
What's freedom units? Pound force?
Yeah, pound force.
Fuck it, I'll see 700 newtons.
Okay. Run the study. Oh, it looks a bit sad now.
So let's click the select coordinate system. I don't know what that is.
Guys, the voice.
Yes, hello.
Can you now?
Hello there. Just got a question regarding the last analysis that you did. Once I open the partial shells, it's coming up in an error. I don't know if you saw that on there.
No, do you want to share your screen?
Sure. How does one do that? Ah, there it is. Can you see the screen?
Oh yeah. Right click on that, the surface body. go activate the configuration,
Ah. And that's it.
and that's it. Yeah,
Sweet. Sweet.
no worries.
The fuck? I'm getting a weird error. Ah, I see now.
Sort list result force. Select. How does one select? Hang on.
Mesh parameters standard. Clear. Advanced.
Ah. Gosh, look at that. It's my guardian angel.
He has spoken. Fly out feature tree. What a lifesaver.
And we want SI units because stuff, freedom units. And we're selecting that little thing down there. Is that what we're doing?
There's
No,
the
wait.
results folder.
Click the go button.
You have to
And
run the study after you
The
create
go-go
it,
button.
right? Yes, you do.
I don't. Where did it go? It didn't seem to do anything. Let's try that again. So we're selecting this thing down here, aren't we, Cam?
Yep.
Like that. Do I click update? Is that what I need to do?
Yep. So now you can look at your resultant forces.
Because I clicked the go button and then it disappeared. I didn't realize I had to click update.
How do you see the? Wait, I think I'm on the same step here. Like, how do you? You don't run the study yet, do you?
I've run the study, yes.
Oh, you
Yeah,
do
you-
run the study. Okay.
You need the results.
Sweet.
Run the study. Oh wow. It's like all bent at the top.
Yeah, if you just get out of that, James. Right click on stress and click edit definition. And you can see in deformed shape, it's all under automatic, it's multiplied the deformation by 2036. See that?
Yeah.
Yep. So if you click true scale, and then hit the tick, that's what it actually looks like. That's how much it's actually deformed.
I like the other one better.
Well, you can't be pleased, can you?
No. Never pleased.
So is that basically like when you do automatic, it's just kind of deforming it relative to like the other bits, basically.
Eh?
So like when before like when you did automatic, it just like deforms it kind of relative to the other like bits that
No,
are
no,
experience
it's-
stress.
No, it's just purely a visualization thing. So you can understand how it is actually deforming, it multiplies it by a certain amount. Oh, it's exaggerated because then when you make it true scale, you can't even tell that it's deformed.
Yeah.
So if you want to look at the way that it's actually failing, it's easier if there's a bit of deformation. Usually you change the scale to something that's not like 2000, so you can actually see the response.
Yeah. Select the edge shown. Update. Under reaction force. Oh yep, 700. read all that.
Oh wait, the forces. I'm just gonna delete that first force. Yes. Run.
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 Ruin.
Oh, he's a sad boy.
In the property manager. Normal.
Oh, they want us to do the list result force. Bang. 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 There we go. I did it, Cam. If you're still here.
Excellent. Very proud of you.
Thank you. I try my best.
I'm going to check on everyone else.
Sure. How do we get to home? Is there a home in here? Ah, that'll do me. What's the next one? Remote loads. Cool.
Okay. You're going too quick for me.
I'm just, just smashing it out.
It's PMS gone.
It's not. No, it's alright. It's just so much shit to do.
Yeah, fair.
Probably should have started it earlier, but hey, we'll get there. Just MD2, Jetta, and what was the other thing? EMA last night.
Yeah. What's going on?
But I haven't got anything due now between now and Sunday, so I can just sort of sit down and completely focus on it.
Yeah. Copy the mesh from the first study, so we gotta go. You have to create the mesh, I'm guessing, again.
Yeah, you got to do the mesh again.
Oh, there we go, done. Save that. Sure. What are you doing now? The beam one? Remote loads?
Yes. Oh, it's always the same. Oh, what was that? Oh, there you go.
Does this one have
Oh.
like? Do you have to go motion study or something? Like, do you have to go
Yeah, it's the one next to it.
ready?
Yeah, yeah.
Like,
Motion studies, something else. And, like animate your part.
wait. You always just pop out of nowhere.
Hey, man.
I didn't even know you were in the chat.
Ah, welcome back. Well, you keep the participants thing open.
Screen's not big enough. I need to get another monitor.
Mate, once you get 2 monitors, you never go back.
I know.
I've got mine like
Okay.
vertically stacked now. It's so good.
Yeah, that'd be heaps good for like reading reports and things.
Yeah, it's great. And I always just get like a sore neck looking left and right all the time. Because I have like my big gaming screen in the middle, and then I had one off to the side, so I'd always look one way. And like one side of my neck would lock up every time I like did a report.
Why you? Wait, why do you have to? Wait, do you have to report sideways or something? What are you doing?
Hey?
Well, do you have your report sideways or something? Like, I don't understand.
No, I've just got like one screen dead in front of me, and then I always had the other screen like off to the side.
Again, you have to look further right or left.
Yeah. So
kinda
if
like
it was on the
forward.
left or the right, I'd look one way, and then look back at the main screen, then look the other way, and then look back. Just used to like wreck my neck.
I'm thinking of putting on like above my current monitor, so like angle
Yeah.
it downwards.
That's what I've got. It's so much better. Then you can like lie back in your chair, and it's great.
Yeah, I'm thinking of doing that. Like,
Mate, get amongst it.
you get a wall mount for it.
I just got a tower that like bolts to the table.
Oh yeah. My table's not that big. That's the only thing.
Mm.
I can't really get a bigger one because my room's not big enough.
Fair enough.
Advanced.
And display select. Yeah, done that. Select. I'll leave it. Clear deformed shape. Oh, right, okay. Is that all it is, Cam? For this clear deformed shape, I just declick that? Okay, cool.
There's options. Result options or just under options. Where did you find that?
What's that, sorry?
So it says like under options, select run, solve the analysis.
Oh, it's in your mesh, right?
Oh, yeah. Oh, if you go in here, I've clicked the wrong thing.
Yeah, click create mesh.
Fuck, I'll just do it again.
Mate, you've got the weapon computer.
Oh, it's like
Down the
literally in there. Okay,
The
I
very
already
last bottom
created
one.
it.
Yeah, that.
Fuck yeah. Okay.
Cool. There he is.
Oh, so like doing that means when you create the mesh, it just runs it straight after.
Yeah.
So I could have realistically just pressed the button. So. It says excessive displacements are calculated with model. I didn't actually fix it anywhere. Just press OK. The Campbell map.
Hey.
I'm getting excessive displacements were calculated in this model if your system is properly restrained. Blah 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 blah.
So you've either put too much force or you haven't restrained it properly.
I don't think it told me to restrain it, but there is a restraint already on there, I think.
Yeah, and what's your force?
I didn't tell me to change it.
Yeah, but what is it? Like,
It's 1,000
Pound feet?
pounds, pound force, yeah.
Yeah, okay. Should
But it doesn't look the same, like, as the first picture. I'll just share my screen. Sorry, James.
Oh, that's right. I made it so you could both share at once.
Oh, really?
Yeah.
So, come here, and then... Like, it looks a bit different to that one.
If I can't see your screen.
Oh, wait, no. You can't see it?
I'll stop sharing mine. Hang on.
Oh, no, it's the same, basically.
Just right click on where it says ready at the top of your feature manager on the left.
Ready?
Down, 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 down. Yep, right there. Click properties. Deselect. No, you don't have large displacement mode. Click OK. Just run it. Just click no.
Sweet, that works.
There. Because if it
Oh, Paul says that right there. I've been
So-
skimming it hard.
what it does is it looks at how far the elements are moving, and if it thinks the elements are moving further than they should be, it'll prompt you to say, do you want to calculate in large displacement mode?
Yeah.
The reason is, if you haven't constrained your part properly, and you click yes, I want to keep running, it'll just push your part off into infinity and calculate forever.
Yeah, gotcha.
So it's kind of like a trigger to make sure that you double check your solution so you don't basically have a infinite loop running in your system.
Gotcha. Thanks for that.
Easy.
Under position. Scientific.
I'll be back.
No worries.
Right click, stress one.
Oh, oops. Mm.
Right click in. Oh, clear sections. When this is the lower edge, it just means the one like opposite to the one we picked here, or like because it kind of looks like it's on the side. Like
Yes.
underneath. I'll just do that. Minus 6,000. Yeah. Okay.
to change this to. Where's my view? There it is. It's hiding.
Oh, my thing's not. Need to
Damn it. Ah!
Mine doesn't look like this. I don't know how to.
What's up?
It's like under result. Like I'm doing the. I don't know if you can see my screen. Doing displacement to wide this bit.
Hang on, I gotta stop sharing mine to see yours and so. Yeah, what's up?
It's saying I have to click on the back face,
Oh yeah, I'm trying to do this too.
but like I don't know like how to
Oh,
get
you-
to that.
Yeah,
Oh,
click there. There you go.
Oh, sweet. Because it didn't look like that color, so I was like, oh, how do I do this? All right. Update. Yeah, I have that. Oh, this is an effort.
This bloody thing won't let me select that face in there.
Right click on it. And there's a little menu that pops up called Select Other.
Oh.
Use that.
Cool. That'd be
Place to
about that in inches. Yeah. Sweet. Thank you.
Do it easy. One of my favorite menus in all of SolidWorks.
I don't understand this. Replace the front cantilever and force applied to it by remote force.
I click back cantilever part.
Oh, it's like this shit. Okay. Right click. There's no open part.
Yeah, there is up the top.
Hang
Hang on, let's have a look. Yeah, there you go.
Thanks
pi-
for that, Campbell.
You're picking up what the tutorial's putting down.
You are welcome.
Okay.
Okay, so that's already been set for us.
Partial external loads.
Sweet. Face one. Cool. Mesh it.
Oh my god.
List SZ at the upper free.
Fuck, okay. What do I have to do here?
Cool.
Confused what we have to do for this bit. Viewing and listing normal stress. Generate a normal stress plot in global
I'll
Z.
right click on results.
It's not spoon feeding it to us this time.
Rush block.
I
Damn.
completed the lesson.
Ooh.
Global Z. That's the right one, yeah?
Yep.
Mhm.
Yep.
Um,
Click the go button.
PSI.
Freedom units.
Freedom
Um,
users. Oh.
Deform shape. Tick that off.
I just left it. You can like declick it later.
Alright, sweet.
Just click the go button,
Go.
and now you can click deform result at the top.
You can run the study. Oh no, you don't. Never mind.
No,
Where?
up. See up the top middle, just above simulation. Keep going up, keep going. Yeah, there it is.
Oh, sweet. List Z. Did you do this? But I don't understand.
Yeah, your thing's upside down, by the way.
Oh, so,
Yeah, it is.
nah.
It's upside down, mate.
Forces backwards.
Yeah,
Okay.
it's bad.
Do I have to do? Do I have to do this thing?
You don't have to, but it's
That's
just
not
right.
anything you don't want to do.
Just right
Basically,
click.
all this.
You're your own man.
How do I?
Right
Can I
click.
flip that? This one?
No, click on you.
That's just flip the force.
Oh right, yeah.
See, I was just testing you.
You done fucked up, mate.
So now, do I have to rerun this study again?
Yeah, I think.
Yeah.
Hey, there you go.
Okay, and do I have to do this thing again? Probably. No.
No, that'll be fine. Just double click on it. And now right click. Probe. And then you just select the edge on the up. Yeah, that one. Hey.
Sweet. Plot the vertical displacement. So I go results. Displacement plot. Advanced options. Do we do anything there?
Oh, this would have been handy beam diagram stuff for the Jetta.
Yeah.
That's alright.
Oh well.
We're out. Sorry, I'm back on your screen now.
IPS?
Sure. You see how the summations of the forces there?
Yeah. Woo, great.
Woo.
Congratulations.
Oh, look, it's a beam.
Alright, let's do the last one. What one is it again? Beam diagrams. Hey.
Yeah. Simulation, new study.
How long does this one take?
Static. 30 minutes, I reckon. I reckon it'll be quicker than that, though.
Sweet.
Oh, I didn't call it shit moment, but oh well. In the simulation study tree. Oh no, down here. Treat as beam. Treat as beam. Alright, click joint group edit.
New study.
At the edit. Calculate. Cool. Oh, do I have to select the beams? Oh no, you just all calculate. Okay, I guess that's fine. Right click beam diagrams. And apply material to all bodies. It's thinking. I think. Yes. Oh, still thinking.
Other shields already have been applied. Defining joints.
Oh Jesus Christ! I didn't think it'd take this long. Maybe this is where the 30 minutes is just waiting for SolidWorks to respond to select the material type.
What's going on?
Just SolidWorks being a pain in the ass took like a couple minutes to open up the material selection.
Yeah, nice. with that big weapon computer of yours too.
Yeah, I know.
Why is it doing this? So right click on a joint. I'm confused what I'm supposed to do on this prepare. Right click one of the joints in the graphics area to verify fixture bodies that make up the joint.
Just right, yeah, that. I clicked that.
Okay,
Ah, yeah, and that pops up. Okay.
Fixtures. Fixed
Okay, so
geometry.
done. We're not actually doing anything, it's just like show us.
Yeah, it's just so you can tell.
Simulate fixtures, fixed geometry. Click isometric. What's that? That's
Yeah, that one.
Oh shit! Oops. Clear. Immovable.
immovable. Select the right one.
Use reference geometry. Is that right? It's to keep visible, yeah. To apply
I
a
don't get-
roller.
Where's that keep visible button? Oh, okay.
Oh, oops. No,
Oh, no.
keep as that. Click the go button. Okay, now we go use reference geometry.
Wait.
Select that bad boy. Select
So
the
do you have to open a new fixture? Like, do you just create a new fixed geometry?
front plane.
Oh.
Yes. Hey, yes, ask again.
For you make a new to do the next one. You have to create a new fixed geometry. Yeah. Like a new fixture.
Yeah. So you go into the fixtures menu. Yes.
Select front plane.
Boundary condition.
External loads. Files.
Wait. Oh, because it's 0 millimeters. Okay, yeah. Cool. I think where's this keep visible thing? Oh, whatever. Oh, it's there. Oh, what? My joints aren't selected. What? Confused.
What? Oh, front plane. Right. Okay.
The diagram looks different.
Okay. Here we go again. Another load. Street. MD2.
Under moment. Yeah, this would be cool to do for the trade up. Doesn't let me select theme 2. Oh, there we go. Get the clipping graphics error. Alright, playing.
Move over, Sky Sieve.
That was ridiculous how much I wanted per month.
I know. Where did my mesh, create mesh go? Oh, it's done it for. Oh, I'm a bit dumb. Oops. Okay. Oh, you can just do it from here. That's cool.
It's like little. It just breaks it up into little segments there.
Yeah. Right click results. Define beam diagrams.
Right click, study. Oh yeah.
Property manager.
Oh, it's like a little curve. Like a noodle.
Oh, that's fine. Oh, we're returning. Oh, so close, but yet so far.
Hey, James, what did you do for the direction? Oh no, it's already got the direction.
All good, all good.
Waiting on a couple of people. Go. That should be everybody. All right, since we've got about 10 minutes left, I just wanted to have a quick run through what you guys will be doing for your assessment and what you should be focusing on, because a lot of people really don't get the idea behind this assignment. Now, it's the same as what I've been trying to push for the last 2 weeks, and that's the lessons behind what you're actually doing, not what you're actually doing. So what I mean by that is there's 1 mark associated with actually doing the exercise, and then there's 4 marks associated with the discussion. The discussion is always a question. So explain the effect of element size and order in FEA. So that's when you're decreasing the size of your elements, what does it do? And what is the difference between, say, a first order and a second order element? And I want you to write a paragraph or enough information to tell me what that means. Now, the images are the important steps. You don't need too many images. Convergent plots are good if they're necessary. They're not always necessary. But the important steps are just things that you think, this is the kind of information you'll need to get the point across. Now, that's these first ones, these first 5 exercises are out of a textbook. The textbook is available for free on UTS Online. Make sure you're using the first edition, not the second edition. The second edition has similar exercises, but some of them are slightly different and it is quite confusing. Make sure you're using the first edition of the textbook. Now for the second part, you're analyzing the JDR shaft, not the one you redesigned, the original one, which is available on UTS Online. And make sure you read through all of these steps and look at where the marks are assigned for that as well. Anyone have any questions on that? Nope. Sweet. With the knowledge that you guys have gotten so far between last week and this week, you should be able to make a start on these textbook exercises. Now, I wouldn't start the analysis of the JDR shaft until you've completed all of the tutorial work and at least read the first couple of lectures or been over them. Really sit down and think about these. These are the important parts. This is where most people lose their marks. It's these questions. They'll put a lot of effort into doing the exercise and taking screenshots, but then they can't explain to me why they've done this in the first place. And that every single one of these is something that we cover in the tutorial work and something that I bring up and discuss with you guys at the start of class so that you understand the actual lesson that you're trying to, that I'm trying to teach you. Everyone happy with that?
Yep.
Awesome.
Do you want like photos of all the steps in each like method?
Only the important steps. That's for you to think about and say, right, this is the kind of information that we need to show. A good example is, I've used mesh control in this area. Mesh control is something that we cover in next week. But say you're like, oh, I've used mesh control here. This is the size. This is why.
All right, sweet. Thanks.
Yeah, Campbell, you said you're doing for part 2, it's analysis of the original JDR shaft, yeah?
Yep.
Sweet.
So not the one that you redesigned, the original one. And then part of it is redesigning or making modifications to the model to make it reflect the simulation reflect real life. So this has example fillets on the 90-degree corners. Now we talked about why fillets are good. Someone tell me why.
Because you don't get infinite stress.
Correct. Reduces the chances of the singularity. Now, I can tell you right now, that's not the only change you'll have to make. I'd say 90% of students just put fillets there and then fix a couple of faces. And they're like, yep, we'll call it good there. But fixing faces ruins the model because you're removing all degrees of freedom from the nodes on that face. And you're not allowing the model to actually react as if it was in real life. So next week, once you guys actually start getting more into this stuff and really thinking about it, we'll look at different types of fixtures, things like virtual walls, which will allow translation away from the wall, but not into it. So it fixes it from moving, translating in one direction. There's a couple of different things that you can set up, and I'll happily demonstrate those when you guys get up to it. Cool. All right. Well, we'll leave it there. Thanks for coming, guys. If anyone has any questions, I'll stick around till 1:30. If not, I'll talk to you guys next week.
Thanks, mate.
Cheers.
Thank you.
Thanks, mate.
No worries.